Hi there. Today we're going to show you what you need to know in order to make the best of working with your QNX SDP8 installation. Specifically, we're going to show you today how you can compile and run programs on a QNX target, as well as what you need to know about navigating a QNX target. We're going to be running our instructions on the QNX Visual Studio Code extension. If you haven't installed QNX yet or the Visual Studio Code extension, please check one of our previous videos where we give you all the steps you need to know to be able to do that. That said, let's get started on using QNX. Some of the prerequisites for this video are going to be assuming that 1, you have SDP8 installed, and 2, that you have all the tools you want to work with for SDP8 installed. In this case, Visual Studio Code and the QNX Visual Studio Code plugin. Another dependency is that you're going to need a QNX target in which you can actually run the QNX code on. In this case, we're going to be using the Raspberry Pi 4, which we have right here. The requirements are that you're going to need a Raspberry Pi that's plugged in, power-wise, it's got an Ethernet connection, and it's got a serial connection. In order to get this set up, you can simply download an image from QNX Software Center, which includes instructions on how you can get onto an SD card. You simply just got to plug it in, and QNX will run. You can refer to that for specific instructions. You can run QNX on any target that you'd like. We're just going to be running it on this for this video. So, we now have our Raspberry Pi connected. We have our Visual Studio Code instance running. One of the first things we want to do is just confirm our target is running. So to do that, you can connect over serial. So I have the serial connection wire, the wires coming from the Raspberry Pi plugged into the USB port, and I'm going to use the screen command line utility to connect. So if I go to /dev, I should be able to see that there is a TTY USB device that is present. That's our serial interface. And now I can use the screen utility in order to connect to that device. And now, if I run the uname command, I can actually see a terminal and I can see that we are running QNX SDP8 on the Raspberry Pi. So this is our QNX instance that is running, and this is our QNX shell. So now in some of the following steps, what we're going to do is we're going to create a new project, a C project, a Hello World project, and we're going to compile it and run it on this Raspberry Pi and show you what the development workflow of doing your own development with the C program would be whenever you're connecting to a Raspberry Pi target. So I'm going to return to the Visual Studio Code, and you'll see a couple options whenever you click the plugin view. Down here, you're going to see commands, and these provide you a little bit of information on how you can configure your workspace, including setting some of the environment variables. Whenever you compile your code, it needs to find the actual QNX installation, where you install QNX SDP8, and there's some settings for which you can do that. All of this is described in our documentation for the QNX Visual Studio Code Toolkit, but a lot of these underlying compiling steps transfer to if you were to do the same on Momentix or right from the command line. If you go to the configuration, you can click the Open QNX Toolkit walkthrough, and you can actually go to Edit Settings to see some of the settings that have been included by default. If you are in the settings, you can go down to Extensions, QNX Toolkit, and you can see some of the default environment variables that have been set up. Some of the important ones that you might want to be aware of is the SDP path. This should point to the SDP path that you installed whenever you did your initial QNX SDP8 installation, because that is where the Visual Studio Code extension, whenever it compiles, it's going to find all of your QNX compilation tools in that directory. So please make sure you have that set up, right? There's also various other options that you can set. So please make sure that you have those configured properly. Next up, what I want to show you is how to create a new QNX project. To do that, you can go to one of the options down here for projects and create new project. We're going to call it Hello World. And it's going to give you various options here for the type of project you want to create. We're going to use the QNX recursive makefile. The QNX recursive makefile, when you choose one of these projects, it's going to introduce a recursive directory tree that allows you to compile different binaries for different architectures. So if you want to compile your C program into a binary that runs on an AR64 system or an x86-64 QNX system, it provides that structure for your project that allows you to do that. So I'm going to click that. I'm going to click a C project. And in this case, I want to make an executable. So I'm going to click that. So now that I've done that, I can see that I have my Hello World project. It built it by default. So I'm going to click helloworld.c just to see the prerequisite code. I can see that there's a file here. There's a line here that says Hello QNX. And we can see below the compilation output. This is the actual command. If you read this properly, you can see that we're invoking the QCC binary. This is the QNX compiler, and you can follow that to the path of the QNX 800 directory, so our QNX 8 installation, into the host tools, which has the actual QNX binary in that part of the installation. If we want to compile this program, how you would do that is you can right-click on the project, you can go to QNX, and you can go Build Active Project. In addition, there's various shortcuts that you can use that are built into VS Code that you can use to build and use to run. You can use those as well. Now, if I actually want to run this program, what I can do is I can right-click on the Hello World instance, go down to QNX, and go to Run as QNX Application. Now, when I want to run it, it will say enter an IP or a hostname. This is because I actually have not told the Visual Studio Code Toolkit about the QNX target. If you're used to running on a self-hosted environment where you're compiling C code and running it directly on the operating system where you've done your development, with QNX there's an extra step because you need to not only compile the binary, you need to transfer it to a target where it will actually run, and you can see the output there. The good news is the Visual Studio Code Toolkit gives you the option to do that. So if I click this button down here, I can actually go to Add New QNX Target Connection. And in this case, it's going to ask for an IP or a hostname. So I've plugged in my Raspberry Pi target to the Ethernet. It was able to generate an IP address. So if I can access that IP address and type it in, I will be able to let the Visual Studio Code Toolkit know about the target. So if I return to my serial terminal, I can type ifconfig, and I can see the network interfaces that are present, and I can see that there's an IP address here that got generated. So what I'm going to do is I'm going to copy this IP address. I'm going to return to Visual Studio Code, click Add New QNX Target. I'm going to paste in the IP address, and now I can see that VS Code is aware of this connection. In fact, if I expand this, I can actually see that VS Code is aware of various pieces of information about the QNX instance. If I expand the properties, it can tell me that it's an AR64 target. It can tell me that it's a Raspberry Pi. It can also tell me what the file system layout of the target looks like. If I were to navigate the file system of the Raspberry Pi through the terminal, I would see a lot of the same outputs that I see here directly on Visual Studio Code. I can also see information about the cores. This is a 4-core system, as well as some of the memory. So it's important to note that VS Code is aware of a lot of those details about the system, and you can see them directly from this interface. Another thing that you can do is you can actually create an SSH connection to your target directly from VS Code. To do that, you simply right-click on the target, click Open SSH Terminal, and you're going to be prompted with a new shell terminal that appears on the output, and it's going to be attempting to connect to that IP via SSH. You're going to have to use the password that was configured on your instance. So I'm going to connect to that. And now I can see that I now have a QNX connection to the target directly through VS Code. So now I want to connect the fact that we have our QNX target to our actual Hello World executable. So I'm going to return to my project view, and I'm going to right-click QNX and go to Run as QNX application. I can see that the QNX application was compiled properly in the terminal. So now I want to show you how you can actually run our Hello World application on the Raspberry Pi target. So to do that, I'm going to right-click on QNX, and I'm going to go to Debug as QNX application. And what this will do is this will actually allow us to run this program in debugger mode. We can see that we're at the first application. You can choose to step through, and you can actually click the debug console, and you can see the output of the debugger as we run. If you just want to run the entire program, you can press continue, or you can step through the program as you would like. Now, one thing to note is if you return to your SSH instance, your connection to the terminal, in the /temp file of your target, that executable will be copied over by the toolkit. It'll do the process of compiling and then moving it to the target and then running it. And you can also run that program directly from the SSH terminal after you've done this process. So if I want to do temp/hello world, I can now see that I can actually run that program. If I wanted to make some changes, for example, I can say, hello QNX, this is my first program on QNX SDP 8. My workflow would be to save it, to compile it, to build it, and then to run it. If I look into the debug console, we can see that the process ran. And if you connect to SSH, you can now run the application directly, and you can see that the changes you've made have come through. In addition, a lot of the features that Visual Studio Code enables about the target properties, you can access those directly from the terminal as well. So for example, if you want to see information about the cores in the system, you can use a command line utility called pidin and do run pidin info, and that'll tell you information about the cores in the system. If you want to see information about what the processes that are running in the system, you can run pidin arg. And this tells you a list of the processes that are running, the arguments that were provided, as well as their process IDs. Overall, what we want to show you is the workflow. You have your compilation that occurs on whatever tool you'd like, in this case, on Visual Studio Code. You compile it for the architecture that you would like, you move it to the target, and then you execute it on that target, in this case, our Raspberry Pi. The Visual Studio Code plugin has various different features. I highly recommend you look at the documentation, as it will tell you how to take best advantage of these features and really enhance your workflow while working with VS Code. And the best way to do that is to simply just search for the QNX Toolkit for Visual Studio Code on your browser, and it will take you right to the documentation. And it will provide you all the information about how to get started, how to launch utilities, how to use some of our more advanced features like the system profiler. Please refer to that, and it will give you a lot of information on how you can get started. Another thing that I want to show and emphasize is anything you do in the Visual Studio Code or on Momentix, you can do directly from the command line if that's something you'd prefer. And I want to quickly show you what that sort of workflow looks like. So in order to do that, the first step you'd want to do is you'd want to go into the directory associated with your QNX installation. In this case, I installed it in my home directory in QNX 800. And in here, you can see that there's a folder for the host tools, a folder for the target-specific tools. And if you want to work with the QNX instance from the command line, The first step is to source your environment. And what this will do is this will introduce the various environment variables associated where the compilation tools can find the host tools, the target tools, the make flags. It brings it into your shell environment so that you can properly build these utilities. The next thing I want to do is show you how you can build our projects that we created on Visual Studio Code from the command line. Because if you were to create your own projects from the command line without using an IDE or the toolkit, you should be able to create the same folder structure yourself and get some of these same results. So if I go to my workspace, QNX projects, I can see my hello world that I created earlier in the video. And I can use the tree command line utility to kind of give you a layout as to what the directory looks like. We can see that we have our C file. We can see that we have a tree of various make files that at the first level tells us the OS, NTO, Neutrino, our QNX Neutrino operating system. We have folders for each of the architectures we want to target. And then we have a final directory that stores the actual executables and compilation objects. We can see that even though we have one C file for Hello World, we can see that multiple binaries were compiled. If you use the file command line utility, you can actually get a little bit of information about what exactly these files are. So if I go down the first tree, we can get information about it, and that we can see that this is a ARch64 executable, and its interpreter is LDQNX64. So this is telling us this is a QNX binary compiled to run for ARch64. Similarly, if you look at the binary that's in the other tree, you can still see that it's using the interpreter for QNX, but in this case, it's compiled for x86-64 systems. So really what I want to introduce here is for QNX, since we are compiling on a host system that's not QNX, it's either Windows or it's Linux, we have a directory structure that's designed to make cross-compilation for whichever target you want, whether it's ARch64 or x86-64. It's designed to make it as easy as possible. Now, we've already compiled this program when we were running on Visual Studio Code. So if you want to clear the contents, you can run make clean, and that will delete all the compilation artifacts. But if you just want to compile them again, you simply just have to run make. It's going to step through the make file structure, and we can see that it's going to create those binaries. Next, I want to show is how you could manually get this to the QNX target if you'd like. You can use the SCP command line utility to transfer it over to your target. So that's what we're going to do. I'm going to do SCP NTO ARch64 O-LE. I'm going to connect to the address associated with the QNX target. If I click back, I can see that it was 10.122.12.21. So I'm going to type that in, and I'm going to pick just the /temp directory. It's an area that you can store files that just last the duration of the execution time of the system. So I'm going to transfer it over. I'm going to type the password associated with that target. And now I can see that that file got moved over. If I want to connect to that target, I can actually also connect to that target over SSH. So I can do SSH root at 10.122.12.21 connect. And now I can see I have a terminal instance, an SSH connection to the Raspberry Pi target. And if I navigate to the /temp directory, I can see all the contents, including my Hello World application. And I can just run it directly from the command line from here. So these steps of running make, building it for all the architectures you care about, moving it to the target, and running it there, these steps that we're showing on the command line do get automated when you're using the VS Code tool extension, or if you're running it on Momentix. But we just want to show that you're free to use the functionality direct from the command line as well, if that's something that you'd like to do. What I also want to show is that a lot of the same steps we've done so far, whether it's done through the command line, whether you use Visual Studio Code, you can do the same things on the Mementix IDE as well. So I've started the Mementix IDE. It is connected to my SDP8 installation. I can click File, New, QNX Project. If I want to build a QNX executable, I'll pick QNX executable, and I will run something called My Application. This will just generate a Hello World program that I can use as a starting point. I want to compile for my Raspberry Pi target, AR64, so I'm going to click that, and I'm going to click Finish. Now I have my own application that I can see here. If I click View, I should be able to show my project view. So we just created our application here on the left, and we can see some of the files that got generated for it. We've got our tree here that has our application that's been compiled for AR64. We have our source code. Mementix will kind of lay out the structure a little bit different than some of the other tools we've used, but the concepts are the same. We have our C file, our source code, and we have our tree that allows us to compile for specific architectures. Now, I can also get a target set up on my Mementix IDE, and I'm going to click QNX target, and now I'm going to put the IP address associated with that target. So I'll give it a name here, Raspberry Pi, and I'm going to provide the IP. And I can see the option to run my application on Raspberry Pi. I'll click Build. And then if I click Run, I can actually see the command line output, Hello World. And this is running on my Raspberry Pi target. And if I make changes, I can, for example, say, Hello World, this is my first QNX program. I can save, I can click Run again, I can see the makefile output, and I can see that it shows up on the console. So at this point, we've showed you how you can compile programs and run them on a QNX instance, what the workflow looks like, what some of the commands you might run on a QNX target. There's a lot that you can do with a QNX system, and far too much that we can cover in a video, but what I'd really like to leave off with is pointing you to our documentation, because our documentation provides us with guidance on how we can use specific features, on what a lot of our APIs do, both in terms of command line applications as well as functions that you can invoke from a C or C program. So what I'm going to do is I'm going to click QNX Product Documentation. I'm going to search that up, and we can actually see the first link is a list of compilations of PDFs and HTML links that we can use to access our documentation. If you scroll down here, you're going to see our documentation for QNX SDP8 as well as some of our other products. I'm going to click that, and this takes us to a page that summarizes some of the documentation. You're going to see some familiar things like our QNX Toolkit for Visual Studio Code. You'll also see our Mementix user guide. And what I want to highlight is our QNX software development platform documentation. If you click here, you're going to have access to a quick start guide, to information about the OS system architecture. I also want to point out that there's very specific documentation on some of the commands we did earlier. So if I search for PIDIN, which was a command line tool that gives you information about the system, you can search for that, and it provides a high-level overview of the sort of arguments you can use in order to interface with your system and get information about it. It also applies to some of the C functions you might run in your program. So if you want to do some dynamic memory allocation with malloc, you can search for malloc, and you can actually see that there is a documentation link for that as well. And on the left, you can actually see all the functions that are related to M here, as well as for other letters as well. So what I want to highlight is anything that you want to do on QNX SDP 8, we have some documentation for it. We have some guidance, and we want to highlight that information for you so that you can make the best out of your QNX SDP 8 installation and your QNX experience overall. Thanks for watching. We hope today's content was very helpful for you in terms of helping get started with QNX and better understanding how to work with it. Please keep an eye out for more QNX content in the future.